Have you ever wondered how lasers, those concentrated beams of light we often see in sci-fi movies, came to be? They're not just the stuff of futuristic fantasies. In fact, lasers are an integral part of our daily lives, popping up in everything from supermarket barcode scanners to surgical tools. But how did they originate? What sparked the creation of these powerful, precise beams of light? Prepare to embark on a captivating voyage into the past. The history of lasers is a fascinating journey of scientific discovery. Our journey begins in the early 20th century with Albert Einstein. This world-renowned physicist and mathematician, best known for his theory of relativity, also made significant contributions to our understanding of light. In 1917, Einstein proposed a quantum theory of light, suggesting that light is composed of small packets of energy known as photons. Crucially, he also predicted the phenomenon of stimulated emission, where a photon interacts with an atom, causing it to emit an identical photon, leading to a cascade effect. Fast forward to the 1950s and enter the maser or microwave amplification by stimulated emission of radiation. This device, essentially a microwave laser, was a critical stepping stone on the path to creating the laser, amplifying microwaves using the same principle of stimulated emission that Einstein had theorized decades earlier. This laid the foundation for the creation of the laser, but it wasn't until a few years later that the first laser would come to life. The year was 1960, and the man was Theodore H. Maiman. This physicist and engineer was about to make a breakthrough that would revolutionize technology and science. At Hughes Research Laboratories in Malibu, California, Maiman was hard at work creating the first ever working laser. His creation was not a product of chance, but a result of thoughtful design and intense experimentation. Maiman's laser was not like the lasers we know today. He used a ruby crystal, a flash lamp, and some mirrors to create a device that produced a beam of coherent light. He called it the ruby laser system. The ruby laser system worked by stimulating the ruby crystal with light from the flash lamp. This caused the atoms in the ruby to emit light of a very specific wavelength. Mirrors at either end of the ruby crystal then amplified this light to create a laser beam. Maiman's creation was a triumph. It was a working laser, and it was the first of its kind. This development carried an importance that can't be overstated. It marked the beginning of a new era in the fields of science, technology, and medicine. His work paved the way for the lasers we use in everyday life, from barcode scanners in supermarkets to surgical equipment in hospitals. Maiman's invention was a turning point, but the laser technology was still in its infancy. From those early beginnings, laser technology has come a long way. Once a mere theoretical concept, today lasers are a practical and powerful tool that plays a crucial role in many aspects of our daily lives. Over the years, lasers have evolved considerably. They've become more efficient, compact, and versatile. What was once a massive and energy-hungry machine can now fit in the palm of your hand, operate on a fraction of the power, and still deliver impressive precision and power. This evolution has been driven by continual innovation and refinement in the field of optics and photonics, the branches of science dedicated to the study of light. Lasers are now a common sight in a variety of industries. In the medical field, they're used for everything from corrective eye surgery to the removal of cancerous cells. They've revolutionized medicine, allowing for procedures that are less invasive and more precise than ever before. In telecommunications, lasers carry voice, data, and video signals over vast distances at the speed of light. They're a fundamental component of our global communications infrastructure, making possible the high-speed internet connections that we rely on every day. In manufacturing, lasers are used for cutting, welding, and engraving. Their precision and reproducibility make them an invaluable tool in the production of everything from cars to computer chips. They've transformed manufacturing processes, making them faster, more efficient, and more reliable. And let's not forget about entertainment. From the spectacular light shows at concerts and festivals to the simple laser pointer used in presentations, lasers add a touch of magic and flair to our visual experiences. The journey of lasers from a theoretical concept to a practical tool is a testament to human ingenuity and the power of scientific discovery. They're a shining example of how science and technology can transform the world, illuminating the path to a brighter future.